actually work through a few today, just kind of getting a little more in depth. Some of you kind of made me start this a little early yesterday, but it was a good thing because you were asking good questions. You should have out a pen that is not your grading pen, but a different color than your pencil, okay? Because we're taking some notes today. On what? Well, limits to begin with. Limits to begin with. On Friday, what's on the calendar as far as what we're supposed to be doing? Grading, not finishing. It should be fully all attempted Friday, but you're grading Friday and then attempting to or working on correcting what you did wrong. That's going to be in your grading pen. True? Okay, so that grading pen needs to be reserved for actual grading and correcting. So I need you with a different color pen because things that we brought up yesterday. You have the cheat sheet out. You have the when you see your things so we can talk about it, and then you have your 27 essentials. What was one of the bullet points that we brought up yesterday on the 27 essentials? Oh, okay, we did talk about deadlines. What else did we talk about? Did we talk about some of these bullet points? True or false? Okay, which are the bullet points that I brought up in class? Does not exist. You were supposed to put that in quotes because what do we answer according to what I've been teaching you since the beginning of the year? Positive or negative infinity, check the signs. So when you guys went to do positive and negative infinity, check the signs on, say, number, did you have any ones where the top was stronger? Number 8. When you went to go do positive or negative infinity, check the sign on number 8. You shouldn't have put D and E. That would have been an improper answer. Instead, you should have been like, well, what did you guys put? Positive or negative infinity, and why? Why positive infinity? There is a positive sign in front of x to the 4th, and anything to the 4th power will naturally be positive. So we have a positive times a positive. He's the winner. He's the strongest. He's the dominator. So therefore, yes, it would be positive infinity. Now, question. What else could get you plus or minus infinity? Check the sign. What else could get you positive, negative infinity? Check the sign. To infinity and beyond, check the sign. That we talked about yesterday. Number which one? Number over 0. Number 2 was the example I was thinking of. Where is that on your cheat sheet? Because it's not actually one of the bullet points. The bullet points are all talking about all of these limits to infinity. How about in the first section? Isn't there something on the cheat sheet about going to infinity? No? There's limits at infinity. Limits at infinity would be what the bullet points are. Limits to infinity, limits at infinity, horizontal asymptotes in your note pen, your note-taking pen. Limits to infinity, you could call these horizontal asymptotes. Do you guys see that whole, the limit is equal to L as I go to infinity or negative infinity? So limits at infinity is like to infinity, aka x is approaching infinity, aka horizontal asymptotes, aka degree tests. But what's right underneath that? Infinite limits. Can you guys open your notes really quickly to section 1.6 or 1.5? Look in your table of contents. 1.6 or 1.5? What's the title of that section of notes? You'll know it when you get there. Infinite limits. Oh, are there some ties from your notes to the cheat sheets, from your cheat sheets to the problems? Is it your job to kind of find those ties? I'm just helping you today. So, underneath infinite limits, what do you guys see? X is approaching not infinity, but a number. Hold on. What would make x approach a number and have the answer be infinite? What did you just tell me? In your note-taking pen, shouldn't you write next to infinite limit, hey, number over infinity? Or sorry, number over 0, my bad. Number over 0 plus or minus infinity question mark? That's our way of remembering. You plug in a value. You plug in a constant. Going to infinity, you do degree tests. Going to a number, if you plug in and get a number over 0, that is an infinite answer. Now hold on. Why is the correct answer to number 2, though, D, N, E? You have to approach from 2 different sides? Wait a minute. Hold on. What part of this cheat sheet is telling us I have to come from either side if I'm approaching a constant? How about the working definition of a limit? We crossed out the precise definition, but what about the working definition? Do you see that, the second piece on the left? Doesn't it say either side? AKA the sides must agree. So what should you have done for number 2? Didn't you need to come from both below and from above? It's a little bit of a mess. Looks like a plus. It's meant to be a minus. Let me get rid of all that for just a second. So when you got 8 over 0, that was plus or minus infinity. Check the sign. True? But to check the sign, for a limit to exist, you have to come from both sides. So how do I come from below? Choosing a number below and then visualizing positive or negative. Another way of looking at it is 8 over 2 minus minus 2. An example of 2 minus minus 2, wouldn't that be like 1.9? And what would 1.9 minus 2 be as you go closer and closer to 0? It's infinity, but which one? Negative infinity. But this one, if I chose something a little bit bigger than 2, then what's going to happen? Positive infinity. What's true about those two? Did you guys write all that work down when you did number 2? Please don't tell me you went to a graphing calculator. If you visualized a graph, that might have been okay. It had a vertical stretch 8 of your basic graph, which had been shifted over 2. And you guys have that in your cheat sheet too, with the right-hand limit and the left-hand limit. But that might be something that you wanted to make a note to yourself as far as number over 0 being particular and kind of tricky, as far as how to remember what to do for infinite limits. Once again, on your cheat sheet and a colored pen, you should have put number over 0, plus or minus infinity, check the sign, and maybe even make a special note of check both sides of the constant or of the vertical asymptote. What? Those are vertical asymptotes? Yeah, every time. Denominator equals 0 and the numerator doesn't. P.S. What else did I give you today? Okay, hold on. Where does the when you see you think worksheet come from? Oh, do you guys see this? When you see is on one side. This is what you should think of doing. So whenever I say when you see you think, this is what I'm talking about. Do you guys see anything that we just talked about as far as when you see you should think in the pre-cal section? That we just talked about in the pre-cal section. Yeah, A6, vertical asymptotes. What did I just say is an indicator of a vertical asymptote? Number over 0, or a 0 of the denominator where the numerator is not 0. Vertical asymptotes always occur at the limit as x approaches a of f of x equaling a number over 0. Another way of looking at it is it's a 0 of the denominator that does not factor away, factor and reduce. Couldn't we also then go back to A5 and be like, oh, the domain of f is the denominator can't equal 0? But are there any other ways that the denominator, are there any other ways where the function cannot exist besides denominators equaling 0? Okay, negatives under a square root. Negatives are 0 in a logarithm. Maybe the vertical asymptotes of our trig functions, which are really just zeros of their denominators. If you rewrite tangent as sine over cosine, cosine can't be 0. Hold on, guys, did we talk about pre-cal this year? Didn't you just open up your notes? Where did we start this year? With a summer packet. Oh! And what was in the summer packet? Pre-cal. Oh dear. Pre-cal. Simplifying complex fractions, domain, graphs, sketches, etc. Where do your notes start though? Let's check it. Section 1.1. What's it say? Ooh. So if your notes start with limits, but your when you see you think starts with pre-cal, oh, better get out our pre-cal notes. Or just get out your summer packets. Maybe your brain for some of you, but for others of you, that's not even going to help. So we have to give our brains some extra tools. Guys, but what did your cheat sheet, your calculus cheat sheet, what did your 27 essentials start with? Not pre-cal, even though it's important. Is it important to, for instance, on the first one, A1, talk about zeros? Have I talked about zeros a lot recently when we started using our calculator? Intersections and zeros, aren't those important? Do we need to be able to use the 0 feature on our calculator? So some of you might need to write a little bit of something about your calculator in here. Some of you might need to write something like, if I'm trying to solve an equation where I have something like, let me quickly get some white space. If I have something like, oh, hey, when does f of x equal 231? In like a nasty word problem. How would you do that problem? And why am I saying this should go under the zeros? Hints and clues. If you're allowed to use your graphing calculator and you knew what this function was, let's say it's something horrible and disgusting, so you're going to plug it into your y1. Could you make this y1 and make this y2? Yeah. But the problem is, where's your intersection going to be when y equals 231? You going to play with your window all day long to get there? You have to play with your x's and your y's to get there. Now you could, some of you would be smart enough to do that, but let's say this was a function f and a function g. You don't even know the number you're aiming towards. Would you play with your window over and over and over again? Or would you, what, Kevin? Bring it down to the axis and say, I'm not going to go to you, you come to me. How do you make it come to you? Exactly. y1 minus y2 equals 0. Where are all the zeros always going to be? What are zeros? X-intercepts. Where are they going to be? On the x-axis. Which x's? I don't know. Expand your x-min, x-max. But where is it going to be? On that axis. It's a lot easier to find zeros than it is to find intersections in word problems with nasty numbers. Some of you might need to write yourself a note. Wait, why am I giving you this whole some of you might need to? What's this for? A lot of calculus kids that have gone before you would say this is what saved them for the AP and the review. What this? It's blank. What'd they do? They wrote on it. That's good. Did they go looking for answer keys online to steal what helps other people when they read this? They might have thought of that, and actually I have like sample answer keys. I have like PowerPoints that when you see the next one, you should think. Like, yeah, I have possible answers for it. But guess what? None of the possible answers would have had what I would have just told you about. Oh, that's good. Oh, I should be thinking zeros whenever I'm setting two equations equal to each other. I should be thinking, well, some of you should also think not only zeros being x-intercepts, some of you forget that, but also if you're solving by hand, you should be factoring whenever you have zeros. Some of you don't do that so well. Anyway, these are things that might pop into your head when you read this, or it might be you face an AP problem, an AP multiple choice, an AP free response, and you're like, oh, I didn't get that, and I should put it here. So you need to familiarize yourself with these different topics so you can be looking out for them so that when you see them, you can write down, summarize, tell yourself what you should be thinking. Does that make sense? So is this something due tomorrow? Heck no, techno. We're going to be working on it over the next 2 weeks. It's going to be due next Friday. Why next Friday? Mock AP is on Saturday. But just because this is due next Friday, does that mean you should fill every possible white space on this paper before we start the actual AP review? I would leave some space. I would put down what you can as far as little reminders, little things you've come across, etc., etc. But I would also leave some space, or maybe even, I don't know, make it an extra copy before you start so you can have one to the mock and one to the actual and see how they compare. But anyway, yes, I will show you answer keys eventually. Partway through next week, I'll put up one sample set of answers for this. But is that necessarily what you need? No. You need to make it your own and say, okay, what do I need to think when I see? Does that make sense? Some of that comes with experience and seeing lots more questions, etc. But guys, let's go down to limits, because that's what you were working on last night, wasn't it? I mean, not entirely, but in 1 through 33, weren't there a lot of limits? So let's look at section B, and let's see if there's anything you can fill in right now from your limit work last night. What's something that ties in together either with the 27 essentials and or the cheat sheet? I have all 3 of them before me. My advice to you is to take all 3 of these home every night with your notes and your forever cards and be trying to compile. Okay, do you see anything that you can fill in? B1, yeah, good. How do we start? The limit as x goes to any a of f of x. Plug in. F of a exists, you're done. F of a doesn't exist. Ooh, give me some options. Well, if you get 0 over 0, keep going how? LH, L'Hopital's, or algebra, right? LH or algebra. What kind of algebra? Well, on the cheat sheet, I think they give you all sorts of algebra. Like you can Rationalize the numerator denominator with like square roots. You can combine rational expressions like simplify complex fractions. You can factor and you can cancel. Cheat sheet gives you some of that, but didn't we also say L'Hopital's works just great? Okay. So, for B1, f of a exists. Booyah, got it after plugging in. F of a does not exist. It's 0 over 0. Keep going. L'Hopital's or algebra. But what's something else that f of a could be? Where I have to kind of adjust. 0 over 0 or number over 0. Good. Plus or minus infinity. Check the sign. We just talked about that, right? Check the sign from both sides if it's a two-sided limit. This one is because it doesn't say a below, a above. It just says a, so both sides. Should probably put something about both sides. So 0 over 0, L'Hopital's or algebra. Number over 0, plus or minus infinity. Check the sign. What's the one other case you could get? Infinity over infinity. Now you might not see it as much when you have x approaching a, but if you got infinity over infinity, you could either think degree tests or L'Hopital's, or both. Degree tests or L'Hopital's, or both. Wait a minute, B2, hold on, B2. Piecewise functions, hold on, 27 essentials. Did you guys go to number 15? You should have, because you were supposed to go to 33. Why am I directing your attention to number 15? It's a piecewise function. Hey, what's B2 talking about? A piecewise function, isn't it? Hey, what does your cheat sheet, the second page on the back, right-hand side about the middle? Cheat sheet, second side, on the right and about the middle. Piecewise functions. Hey, okay, let's summarize then. How do we take the limit of a piecewise function? The bottom and the top, I'm going to change it just a little bit, Kevin, to below and above. Is that okay? Because depending on the inequalities, the bottom and the top, be careful. What part is that answering? Isn't it answering this guy? Don't we have to take limits to do the continuity? Do you guys agree? Why is this not working? No idea. Hold on. You see it? I see it. It's drawing over there. We're going to do that. We're going to do that. We're going to do that. And we'll try again. Jack, can you go hit escape on the keyboard? Yeah. He's okay. All right. See, I don't know the difference. Okay, continuous. What's an application to finding the limit as x approaches a of f of x as a piecewise function? It could be asking, oh my goodness, B3, continuous. Oh, anyway, don't we need to come from below and above? Now, if you're writing this on the when you see you think, you should be saying the limit as x approaches a from below f of x and the limit as x approaches a from above f of x. Careful, it's not continuous. That's B3, so don't say they have to be equal to each other, but you can explain to yourselves how to do it, looking at the cheat sheet or looking at this example, how to do it. How do we come from below? We plug into the less than piece. True? What's the less than piece? X squared minus 8, which would be 4 minus, sorry, a, not 8. So could you explain you have to come from below and above? Looking at the inequalities, and the below and the above plug into the appropriate piece, right? 0. What? I don't see a 0. Sorry, Colby, I just need you to speak clearly. Why are you talking about 0? I'm not sure why we're doing 0, though. I think we just need to plug into the bottom piece and end up with 2b minus 8, and then realize that we can't really solve quite yet without knowing a and b. Unless you're just trying to like make up numbers and get them to equal each other. Is that what you're trying to do? Okay. So that's continuous. We need these two to be equal, but what's the other clue for this problem? Now, some of you yesterday, someone came in and was like, we didn't learn this. We didn't do a problem like this. And I was like, yeah, we did. But you didn't pause. You didn't in the beginning of your notes, because in the beginning of your notes we learned continuity before we ever learned about derivatives. So could this problem have come up in the beginning of your notes? Not in the limits and continuity section. Where could this have come once we learned derivatives? Now, did we talk about making functions, piecewise functions, continuous? Yes. But did we do both of these at the beginning of the year? No, we didn't know how to. But now do we? Well, we should. Guys, how do we make them differentiable? Limit of a piecewise function, but of the derivative. I need the slopes to match, and if the slopes don't match, I got myself a sharp point and it's not differentiable. Now hold on, wait a minute, differentiable, is that underneath the limit section? Nope. Do you think differentiable might be under the derivative section? Yeah, possibly. I'm just trying to find where. Find the derivative, average rate, instantaneous, find the equation, horizontal, vertical. Well, that's awkward. Find the derivative. Oh, there it is. C13. C13. What's C13 say? Given a piecewise function, show it is differentiable at x equals a, where the function rule splits. What's it talking about? Piecewise function. How do you show it's differentiable? We'll take the limit as x approaches a from below the derivative and the limit as x approaches a from above the derivative. And what needs to happen? They need to be equal. So, just like we talked about with piecewise functions, plug into the below piece, which is going to be this guy. If you guys want, I could write it up here. G prime is equal to 2x is the derivative of that piece, b is the derivative of that piece. This is for the below, this is for the above. And why didn't I write at? Because I don't know, they have to match. And if they don't match, it's a sharp point, and so at does not exist as far as the derivative. So plug into 2x, the below piece, will that be 4? Plug into b, well, there's no place to plug in. B is B, so okay. Oh, hey, b is 4. And if b is 4, can't we plug in and find out what a is? Okay, what am I trying to show you? Let's take a deep breath. Let's let it out. Do you have a lot of information in your notes? Do I want you to keep accessing your notes? Yeah, because that's where I was teaching these concepts the way that I thought was best in preparation for the AP and future topics. But what's the problem with your notes? Maybe. Hopefully not. Aren't there a lot of pages? Look at your table of contents. What page did you get up to? There's a lot of pages. Okay. What's true about how many essential topics this packet says there are? 27. Shh. This is the thickest packet out of the 3, I think. 27. Is that narrowed down from your notes? But does that have everything? No. Didn't we just have to change a couple of these bullet points and make a special point of them, etc., like what they're actually talking about? There's one more I actually want to talk about really quickly before I finish, just seeing whatever other questions you guys had. We might be adding to this a little bit, but we're trying to make this our own. Look, look, look. We're trying to make this our own. Something that we can use to study, which has not only notes, but also examples. Lots of examples. What else is there that we could make our own? The cheat sheet. Is it good? Yes. Does it have too much? Yes. We need to narrow it down. Does it have some examples already worked out for us? Yes. But do we still need to maybe make this our own and make it particular to what we need? Yes. This is more like a college review sheet, which is good, but in some ways, when they say D&E, actually that was the other one, we say, no, actually, we're going to try and answer positive, negative, infinity. But what's the one other I want us to try to summarize? You know what one of the saddest things is on the AP? If a kid reads a question and doesn't even know what it's asking. That's so discouraging. It's like, I don't even know. That's what I'm going to do. Or your brain jumps to the wrong thing to do. Now, there's always the issue of, like, you forget to do a block prime, or you forget to, I don't know, do some sort of, like, FTC part 2 integral from a to u is f of u times u prime. Like, you forget some little pieces. Maybe you do a disk instead of a washer. You should never do that, but okay. Maybe you do a pi r squared when you should have done a side squared. How many of you misread question on the test when it said square, you did a circle? I don't know why. I don't know why. You tell me why. I don't think you'll know why either. But anyway, coming back. Our brains are dumb sometimes, but that's not to say that, pause, that's not to say that there are a lot of things that we could get right if we just learn how to read and jump to the right process to do. Does that make sense? That's what this sheet is for. Okay. Have these all together as you're working. Try to compare everything. Try to compile your resources. There are some seniors recently that have been bellyaching quite a bit about English and poetry, analysis, etc., etc. Lots of essays they have to be writing. Maybe you've been hearing it. I've been hearing it. Some people feel very unprepared for what they're doing. Now, to some extent, is there a time and a place for throwing people in the deep end and being like, you got to learn, and here's the best way? Yes, I think a lot of parents, at least, would agree with me. Sometimes you just got to throw them in the deep end, and then they'll learn as they get there. And we'll be there to pull them out if they can't swim so well. However, is there also a place to being given as many resources as possible and learning how to use them wisely? That's what I'm trying to do. Am I throwing you in the deep end in any way, shape, or form into this 27 Essentials packet, or eventually into our mock AP, or eventually into our actual AP? No. I'm going to give you resources, but what is your choice? How you use them. And not just use them like, okay, I just have to memorize, but no. Critically analyze and be like, wait, is that really what I want to think? For instance, can we go back to those bullet points about E from yesterday? Is it the best thing for your brains to say, E, he always wins? No. But did you read, those of you that asked me that question, did you read the bullet point right above it that actually answered the question you were asking me yesterday? What did the one right above it say? Whenever you have a negative infinity, sometimes they don't follow the patterns either. Because a negative, for instance, in number 11, if you plug a negative into something cubed, what's going to come out? A negative. So you're going to negative infinity, you plug it in, a negative cubed is a negative times a negative is a positive. It's not going to act the same way as a positive infinity. But what is a more pressing concept that you guys have to understand as far as negative infinity? E. Because E does dominate, but E only dominates when or only dominates if. When does E only dominate? When or dominate if? If when you plug in you get E to the positive infinity, he's dominating. Above everybody? Well, dominating polynomials, dominating trig, dominating... Does he dominate 10 to the x too? No. I'm not treating you like dumb, though, because I said that on purpose. A lot of people will get confused by that. But I thought E dominates everybody. Why would E to the x not dominate 10 to the x? E is 2.71828. 10 is stronger than 2.718 to 8. So when you get into exponentials, they tie. You got to look at their bases. They tie. But E dominates over everybody except for factorials and stronger bases. Okay, that could be something you got to write down, right? But most kids know that E to the infinity dominates. The problem is they don't keep a lookout for E to the negative infinity. Do you guys realize I'm talking right now about numbers 11, 10, and 11 right here? If you approach positive infinity with E to the x, he's going to win. As long as there are no factorials, which there never will be in CalcAB. No factorials and no bases that are stronger than him. 10 to the x, 3 to the x, 4 to the x, a million to the x, whatever. Which, in this example, the only other guys are polynomials. Poor little piddly x squared and x cubed. They got nothing on E to the x. If he's going to positive infinity, he wins. Which is why number 10's answer should have been positive infinity. But number 11 didn't work the same way. Regardless of the answer, it didn't work the same way. Because now all of a sudden E was going to negative infinity, and guys, I would, in your note-taking special colored pen, be writing down E to the positive infinity, yeah, dominates, but E to the negative infinity. Swoop, there he is. He's super strong here, but here, what is he getting brought down and down and down and down and limited by? He's 0. If E is to the negative infinity, all of his power has been drained. Hercules, let's use Samson. Samson, his hair's been cut. There you go. Poor little guy, he lost everything. Or he's losing everything. Which means, who or what made this answer positive infinity? It was not the E. It was not the E. He would have been 0. Who made it positive infinity? That guy? Nope. That guy? Actually, nope. Why did this guy make the answer positive infinity for number 11? He was the strongest. Now let's see if you actually understand this. So what would be the answer to number 11 if instead it had been the limit as x approaches negative infinity of e to the x plus 3x squared plus 4x cubed? Why negative infinity? He doesn't matter. He is a positive infinity no matter what. The plus and then anything squared is positive, but he would have been negative. And who's stronger? Who's dominating? When e is to the negative infinity, the strongest polynomial. Do we kind of get the idea of domination? All that to say, these packets are good, but they need to be improved upon, and the only one that can do it is you. And I'm going to try to help and guide, etc. But when you guys come in tomorrow, don't worry, we're going to go over questions all the way to the end of 33 and see where you guys got stuck. We're not grading, we're just seeing where conceptually you're like, I'm stuck. The whole grading and figuring out your little mistakes will happen on Friday. But when you come in tomorrow with questions all the way up to what number are we going to? 1/3 of 100 is about 33, so 66, but technically this went to 34, so 67 would be nice. I want you guys to not only come with questions on problems 35, because technically you should have done 34, it was at the very bottom of the page, 35 to 66 or 67. I want you to also come with questions on the cheat sheet, and maybe even questions on the when you see you think. Why? Because you should be using them anyway, right? No, not using resources? No? All right, well, here we go. Okay. Do you guys have any questions on numbers 1 through 14 that we haven't gone over? Either the notes, the bullet points, or the examples themselves. Anything that you got stuck on? Or need clarification on? Or disagree with? Okay, how about the next page? Talking about different types of discontinuity and non-differentiability, whether it's a vertical tangent line, whether it's a sharp point, whether it's not continuous and so it couldn't be, or IVT. Any questions on 15 or 16? How about this one, the basic differentiation rules? Pause real quick on number 17 and do a teaching moment. Could some of you be like, stick it to the man time, there, no multiple choice? I mean, you could, right? Because it's just a long answer, just fill in. But what are you going to have to be doing on Friday? Making a match to the answer key, and guess what the answer key is going to be? Simplified. But also, haven't I told you at some time during the year that when you do something like, oh, I don't know, product rule, why am I going to not just bring down the 2, but also do a times 1? What am I doing? Chain rule, derivative of the inside. This time was 1, next time might not be. Second d first plus first d second. Why am I going to take time when you could have boxed it and I could have been done to come over to go change a custom pen, oh, to make sure my custom pen is green from period 1, and to say, hey, are you paying attention? What's the AP going to ask you to do? Factor what's in common. So what's in common? 2 what? That's not in common. Oh, it's except I didn't take my derivative. There you go. Second d first, first d second. Look at Colby blindly following me. This is dangerous. Life lesson, don't do that. Okay, so what do we have left? All right. Whew, I factored. I got the green chick. Now box it and be done. No. Who would leave that? Some of you would leave that, but don't. X plus 3, and we end up with 2x plus 1x is going to be 3x, and 3 minus 1 is 2. Ha-ha. No, don't distribute. Leave that factor. You silly goose. But good try. No. Okay. But I had some questions on, derivatives of inverses. Do we have a forever card on this? Do we have examples in our notes? Is it still hard? Okay. So what do? Don't we right away just follow the card and say, ooh, maybe I should get something I can actually write on? Boop, boop. Don't we say 1 over f prime of b? Who's f prime if f is, oh, that's easy. F prime is equal to 3x squared plus 1. So can't I say this is 1 over 3 somebody squared plus 1? Who? 10? 10 is the x of the inverse, which is the y of the original. I need b, and to find b, I need to plug in and say 10 is my y value. But what did I say about the AP? Trial and error. Someone remembered and looked at their notes, or maybe both. Plug in 0. 0 plus 0, 10? No. Plug in 1. Is 1 cubed plus 1? No. Is 2? Wait. 8 plus... Oh, it's 2! So what am I going to do? I'm going to go ahead and plug in. Okay, we can all just say it's 2. And then we can be done. Equals 1 over 4 and 3 and 12 and 13. Dun, 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 dun. No. But what would have been a multiple choice answer?
Yes.
And you would have gotten it wrong. Let's cheer about that later. Anyway, so pause. Does this make sense? They wanted you to plug in 10. The question was begging for it. I mean, actually, the math was, not really the person that wrote the question. They just say you should understand this. 10 is not an x of an inverse. So we have to be careful and plug in the other guy. Kiddos, I'm not going to do that one because I have to at least, leave one for you to do. All right, so what about the next page? Why am I going to pause for a second on tabular data? Is there a forever card on tabular data? No. Thank you. I appreciate that. So, if there's no forever card on tabular data, it must not matter. Good. Thanks. Why? Shh. Focus. Love you all, but shush. Why am I going to go over here and now make a point of going to a blue pen? What is this table chock full of? So many clues, and you need them all? They're trying to misdirect you one way or another. Do you guys remember a certain test from first semester where I had a very easy question if you would have just done the derivative rule first and then plugged in? Well, I remember it because it left an impression. It always does. How do you find h prime of 2? Oh, just go find f of 2 and g of 2, and yeah, I'm done. What did you not do at all? You totally ignored it. Product rule. Do the rule first. Throw all these clues in a handy-dandy notebook, close the notebook, and say, okay, what am I supposed to do? Then go look at your clues. The clues don't tell you what to do. They say what to do with what you have done. Ooh. But instead of looking at the clues and getting distracted by all this, you need to come back and say, what's the main idea? Oh, there's a life lesson in that too. Main idea is to find his derivative, and his derivative, isn't that second? Be first plus first. Shouldn't this be easier than taking normal derivatives because it's just your forever card literally written down? But we're supposed to be finding this at h prime of 2. Take a step back. It's h prime of x when x equals 2. So isn't it going to be all of this when x equals 2? So how do you finish this problem? I need g of 2. Well, go get him. I need f prime. Go get him. Plus, I need f of, go get him. G prime, go get him. Does it make sense? Maybe in your notes pen, should you be doing something like a, hey, be careful. Do the calculus first, then the clues. How are you guys doing on number 7 and 8? Because this ends off the problems you were supposed to be up to today. Any other questions? Did you remember what normal meant? Just real quick, equation of the line tangent, maybe in your note pen. Maybe you should do something like y minus f of a is equal to f prime of a times x minus a. But what should we change for normal? Nothing, nothing, everything. Just kidding, only a little bit. opposite reciprocal for a perpendicular line, but everything else with point slope stays the same. Careful with shortcuts. But you guys were asking me about these ones down below, yeah? Hey, didn't number 30 just say find an equation of a tangent line and use it for local linear approximation? Do you remember the calculus in 20 minutes guy, how he was like, hey, we can use tangent lines in order to, anyway. How do we use tangent lines to estimate? We find the tangent line. I mean, you could draw it, Colby, but I don't know if I want to necessarily take all this time to figure out what that graph looks like. Oh, yeah. But if I'm using the tangent line, couldn't I say something like y is equal to L of x is equal to f of a plus f prime of a times x minus a, and say, I need to plug you in. And when I plug you in, I'll approximately get. You're plugging into a tangent line. So my question is, where's the tangent line here? Wouldn't it skim? Okay, keep drawing your tangent lines if you haven't yet. Skim, 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 skim. Draw your tangent lines. And then you tell me, if I plug into the line, instead of the function, the actual value would be the f of, maybe not the f of a, maybe f of b, because a is our tangent line. Plugging into the tangent line, how does it compare to plugging into the actual? You tell me. How is plugging into him? It's called an over-approximate versus an under-approximate, which is a great AP type question after they have you approximate. Bye, cool kids. Toodaloos. Oh, P.S. Do you guys notice how this guy's going to be over and that guy's going to be over? What's in common between the two graphs? Increasing, decreasing. That's not in common. That's a thing. Bye, guys. Toodaloo. Later, gators. Where am I when you see you think? Where'd they all go? Maybe we have them all?